and go a little over time because we've got to have this discussion. But boy, we're not going to be able to show you induction cooking or heat pump water heaters live unless we get going again.
Yeah, so let's do that. So I'm excited to talk to you about heat pump hot water heaters. We actually delayed the construction of our house for about 4 months, waiting for the first production line versions of these things to come off of the GE production line. And it was well worth it because it's game-changing technology. A lot of people are familiar with tanked water heaters. A lot of people have had them in their house before the advent of sort of tankless hot water heaters. And then sort of the golden boy of hot water heating was the tankless hot water heater for a number of years because they would tell a story that, you know, your tanked hot water heater would heat up and then it would cool down, and then it would heat up and it would cool down, and therefore the efficiency of it was really bad. And so you have to go to these tankless hot water heaters. The reality is that a gas tanked hot water heater did that heating up and cooling down, because you couldn't insulate all the way around the tank. The bottom portion where the flame was, you can't insulate that area. And so it immediately, that steel tank would start to lose its heat. And then there's a flue in the middle of it, right, where the gases go up and through, and you can't insulate that portion as well. So you had a tank that really didn't work very efficiently when you have a gas tank. And therefore the tankless was more efficient than the tanked version of that thing. And the tankless version is about 90, the tanked version is about 60% efficient on a gas hot water heater. The tankless is about 93% efficient. But guess what? An electric hot water heater is actually closer to 100% efficient because it has insulation all the way around the tank. Okay. The problem with electric tanked hot water heaters is you have two 45 or one 4500 watt resistance heater in there that spikes the current when you use it. And so therefore it's not very adaptive to the grid, and especially in 4 to 9 periods, when that thing turns on, it spikes and it uses a lot of energy all at one time to heat that water. So then came this thing called the heat pump hot water heater. And a heat pump is something you all have in your house and you use it every day. You all know what that is? Any idea? Heat pump? No, right? A lot of people don't know what a heat pump is. A heat pump is a very, very simple device.
Your air conditioner is a heat pump.
If you have an air conditioner, but if you don't have an air conditioner, I can still tell you, you have a heat pump in your house. Any idea?
Refrigerator.
That's it. You got it. Yes. Congratulations. Okay, your prizes are on the way.
Awesome.
The refrigerator is a heat pump, right? It takes the heat that is in the box, that insulated box, and it throws it on the floor at your feet. And that's why it's warm down there at your feet, because it's taking the heat out of the box and is throwing it on the floor at your feet. The heat pump hot water heater works the same way, but it takes the heat out of the room that it's in and throws it into the water at a very, very high efficiency. So I mentioned that the heat pump, or I'm sorry, the tankless hot water heater will operate at about 93% efficiency. These things operate at 350% efficiency because they're taking the warmth of the air that's in that room and pushing it into the water in a way where it doesn't have to make 100% of the heat itself. And so that's why it's so efficient. And again, it has time, you can buy them with timers on them so that they lock out in the 4 to 9 period, and they still have energy in them. There's stored energy in that tank. My wife and I could take multiple showers in the 4 to 9 period when we've locked it out. And because it's got 50 gallons of 200 or 130 degree water in there, it's not a problem. So you can ride out the 4 to 9 period with no problem at all. You can also lock out the resistance heaters in the 220 versions of these so that you don't use them at all and you only use the heat pump hot water heater And that's what we do as well. So those two things just save a ton of energy. And it does a couple of things that are quite amazing, and actually dehumidifies and cools the space that this thing is in as well. So we have it in our garage near a crawl space that it gets very, very humid. And it just dehumidifies the whole thing, again, for free. It's sort of a twofer, because we might have to have a dehumidifier in there if we didn't have that unit in there. So there are a number, and you can see them in practice here. And they are the tool that we talked about as a thermal battery. They act very nicely as a thermal battery. And Nick put together some graphs from his own house. Nick, you want to talk through these a little bit?
Yeah. This is a sizing chart. The blue bars are gas water heaters. The orange bars are heat pump water heaters. Notice that the 240-gallon on the left chart, the first two bars, the heat pump water heater 40-gallon has lower first hour rating than the gas equivalent. Move to the next two bars. The gas 50-gallon and the heat pump water heater 50-gallon. The heat pump has lower first hour rating. Not crazy lower, but a little bit lower. And so to get back up to that same amount of first hour available hot water, you need an 80-gallon heat pump water heater, which is the bar on the right. That's because the recovery rate of heat pump water heaters are lower than the recovery rate of gas water heaters, gas tank water heaters. So what this means is if you're used to a 50-gallon gas water heater for a typical size building, you might need an 80-gallon heat pump water heater or a 65-gallon heat pump water heater. It's a good rule of thumb to upsize the tank a little. But I will tell you that the 50-gallon heat pump water heater we installed for our ADU for the couple living there has been more than adequate, not a single issue with supplying a couple. And you can see on the right, the amount of electricity it's using is on average less than 1 kilowatt hour a day. Really efficient.
And you've got the electric resistance heaters locked out as well. Correct?
That's right. But I haven't done anything like locking it out during 4 to 9 p.m. because these are my tenants. I don't want to put them out. It's just running in heat pump mode all the time.
All the time.
I see it turn on about twice a day.
And Nick, in relation to the upsizing, and we started to have this conversation, but I don't want to make it lengthy. But could you avoid going to an 80-gallon by increasing the temperature to 140 degrees and then putting a anti-scald valve in?
Mixing valves, sure. Yeah, I've tried to keep this simple for early adopters to go to their plumber and say, hey, I want an 80-gallon. But absolutely, you can have a higher temperature set point with mixing valves at the unit. This is how the 120-volt units are mostly designed. So that increases capacity because you're storing more heat in the tank and mixing it with cold water on the way out of the tank. Yeah, that's another good solution.
Yep. It's less expensive to do it that way, and we run ours that way. And so it's an alternative if in fact you can't fit an 80-gallon in your space for a reason. So I just want to make sure there's, people see options as well. Fantastic.
Jane brings up tankless. Tankless somehow has sunk into our consciousness as efficient. But gas tankless use gas, and so they're not nearly as efficient in terms of greenhouse gas emissions as a heat pump water heater. And if you're comparing electric tankless, as people tend to do, they think, well, electric's better, let me do electric tankless. Comparing that to a heat pump water heater, there's no comparison. An electric tankless will use 3x as much kilowatt hours as a heat pump water heater. So the electrification, decarbonization trend needs to be heat pump water heaters. Absolutely.
Yeah. And David Nerb piped in and said that California Air Resources Board is planning 2030 targets for phase out of sale of gas, space, and water heating appliances, meaning that after 2030, you're not going to be able to get those things or parts for those things. So it's going to be a problem. And so planning ahead now is going to save you in the long run for sure. All right, and there's so I work in multifamily and various building types, and we have come to some conclusions about these things. And we are currently in the process of building the plans for one of the most efficient multifamily buildings potentially in the country as a result of the EPIC grant that we were working on. And we have changed our thinking about these things significantly. Centralized, as I mentioned earlier, water heating was the way of the past. You would put 2 gas-fired burners on the roof with a big tank, and then circulate that water continuously throughout every unit, because there's only so much time to tap for hot water that people in apartment buildings will stand. And so it can't be that long, and therefore you need to run this loop continuously. And that loop oftentimes used more water than all the showers and everything else that is happening in there from a hot water perspective. And so from that standpoint, we wanted to get away from that. The other part is first cost. To run all this copper throughout the building, the plumbers are generally the most expensive trades on the site. So for them to run all of the copper and get the balancing valves correct, so that you end up with this person at the very end of the run unit still getting the same time to tap as the person closest to the hot water tanks, is nearly impossible. It's very, very hard to do. So we've gone to a couple of other configurations that have benefits to them. One is the shared configuration, where we put 2 hot water heat pump hot water heaters in a alignment through a chase to serve 6 to 8 units going up through a chase. The benefit there is when this unit goes down, the centralized unit goes down, the whole building goes down. When this chase goes down, 6 to 8 units in the building goes down, not the whole building going down. This unit, once it's installed, maybe has a 6-month warranty. Oftentimes we've seen no warranty, or just 6 months on the electronics and not actually on the pumps and valves and other things. This has a 3-year warranty on the heat pump hot water heaters when they are in a shared configuration like this. When you go to a single hot water heater for a unit, and again, this is not the optimal configuration. I would have loved to see them put this hot water heater closer to the usage, because there's heat losses here, but not nearly the heat losses that you see in the centralized unit, because you have one unit serving these. That means for the developer here, hear me, you only need a cold water line to each unit. That's all you need. You need a cold water line that shows up here and you're done. You don't need to plumb hot and cold. This needs dual plumbing throughout the building and a recirculation line. So the complexity of the plumbing is really complex. This is less complex in the shared configuration, and it's the most simple and the least amount of plumbing dollars that you're going to spend is the individual. The other benefit here is that that tank, when used with a sole unit, has a 10-year warranty. Here in centralized, you have to have somebody on call 24 hours a day in case that unit goes down. Here, less so, but still you need maintenance to be able to get in there and figure out what the problem is and potentially replace one or both of those units. Usually one can back up the other. But in this configuration, only one unit goes down if this thing goes down, and it's covered under warranty for 10 years. So for my developers, this is a no-brainer. I keep on telling them, you don't want to be in the hot water business. It's not the business that's profitable. So to get them out of the hot water business, and the gentleman who asked the question before, if there's a configuration change like this that's possible in your buildings, there's money to be made here, because the incentives to switch over to these heat pump hot water heaters is really rich right now, including the electrification and the wiring for these things. So wanted to go through the comparison of those 3 potential ways of wiring the buildings. In the slides, you can see more rationale and detail on it, but we don't have a ton of time, so I'm just going to skip through those. You can read through the comparison. You'll see some photographs and the pros and cons of each going through that I touched on very quickly going through. Next, we're going to go through a heat pump clothes dryer demonstration, and Nick is my hero because he actually swapped out his gas powered clothes dryer for a heat pump clothes dryer at the time when not a lot of people were doing it. And so I was very curious on how it worked for him, but he's a total inspiration. Nick, you want to talk about the heat pump clothes dryer?
Yeah. And before we do, question on solar thermal water preheat. It made some sense when the boiler was gas, right? Reduced gas usage. It was prescriptive standard on all multifamily buildings because of that. But when you switch to electricity for water heating, as we hope you will, heat pump water heaters, it makes sense to pair those with PV, because the PV can power the electric water heaters better than solar thermal can. And because heat pump technologies don't tend to perform as efficiently when they're getting pre-warmed water into them. They want to stratify their tank, cold water at the bottom, hot water at the top. So for that reason, the best practice is not solar thermal anymore. It's PV plus heat pump water heaters.
Exactly right.
Now, yeah, my gas clothes dryer crapped out. I couldn't find a contractor to put in a new drum. So I took that as a sign to research this electrification thing a little bit. This is 3 years ago now. And I found these heat pump dryers. Reviews were mixed, but I found one that got good reviews by Mealy, and I went and figured out how to install it. And as I said before, it's a 120 volt, 20 amp circuit, not 240 as many electric dryers are. It's a slightly reduced, if you could hit click, Robert, and show them the picture of it, slightly reduced capacity. Maybe the next click. Yeah.
There you go.
You see it's a slightly narrow size, more than enough for our family of 4, though. This is the stacked unit in the ADU with the Mealy washer below it. But I found a universal stacking kit to stack this Mealy dryer on top of the LG washer, plug it in right to the existing outlet in the closet. And the beauty of it is they use that same heat pump cycle to take the moisture out of the hot air as it comes out of the drum, condense it, and pump it down the same drain the washer uses. So that dryer vent becomes a thing that's a vestigial organ. You don't need it anymore. That 150 CFM that a gas dryer or an electric dryer pumps out continuously that you then have to condition to replace is not needed with a heat pump dryer. And it's got an extra filter in the bottom left corner to protect the coils. And we're 3 years in and we love it. Find it's gentler on the clothes than our old gas dryer was. It adds maybe 10 minutes to a cycle, so 1 hour and 10 instead of an hour. But the rumors that I read about them taking hours and hours and not being feasible just turned out to be wrong. And you can see it's costing us $3 a month to operate.
That's awesome. So Nick, you continuously leave out the favorite part of my story, your story. Yeah.
That my daughter's bedroom door was right there at the dryer. And when the drum cracked, I started thinking, are these combustion byproducts now more present in our space than they would have been, or were they already present, perhaps leaking through the gas infrastructure? So when I thought about that, it made the conversion to an electric dryer much easier.
Yeah, that's the kind of thoughtful thing. I see that all the time, that the vent for the gas appliances is right below the window, for the kitchen or whatever. And the fact that it was right below the window for your daughter's room. I know by code it needs to be 3 feet away, but sometimes I don't see that, especially in retrofits. And my next door neighbor put in, amazingly to me, put in a tankless hot water heater right below their kitchen window. And I just know that that's, coming in their window in a way which is not good for their health. But, I digress.
All right.
Yeah.
With that, why don't you you got a couple more slides. Go ahead.
I just got a few. Yeah. A friend of mine was building a pool in his backyard. His wife had health issues and wanted to keep that pool at 85 degrees continuously. And, was considering gas and went with this unit, and they're thrilled to death because It cost a little bit more. So this unit cost 4,000. Comparable gas models are about 1,000 to 2,000, so maybe double the price. But in the first year, they made it back up. So this unit estimates to save 5,000 in the first year alone, and then over the course of 10 years, that's an incredible amount of savings. So heat pump heaters for pools really do work and really do save money, especially in Los Angeles. This is a fireplace, and I was at the Builders Show in Las Vegas a number of years ago, and went through a lot of gas-fired appliances that were actually being fired inside the hall, and I thought that was kind of crazy. And then I walked by this one, and everybody was putting their hand out toward it, and I did the same, and it was completely cold. But it looks exactly, like a fire, and it kind of blew me away. But they are LED lights, and they are paired with a water vapor system, and they look identical. And if you wanted to get some heat, you could put a resistance heater in there, and it would not negatively affect your Title 24, and it would keep all of the pollution that is normally associated with fireplaces out of your project. So it's a really generative thing. And then Nick put in a heat recovery ventilator. And Nick, you want to talk about that real quick?
You heard me okay through the computer?
Yeah, perfect.
Okay. This is not a necessary appliance for conversion to electricity, but it is a great supporting cast member, let's say, for indoor air quality, because it's going to save energy by swapping the heat from the inside that you've paid money to condition with the incoming fresh air from the outside. That reduces energy use of your space conditioning system. And maybe more importantly, you're going to now duct the fresh air throughout your house through little 4-inch ducts, and you're going to pump fresh air behind closed bedroom doors at night. I've got an exhaust thing right here in the kitchen and the bathrooms, so it's continuously removing stale air from the bathrooms. And if you provide 20 CFM continuous in your bathrooms, you don't need the bathroom vent fan anymore. So with the HRV, I was able to vault the ceiling in the ADU and not install a bathroom vent fan. And there's significant compliance credit due to the energy savings of these. So I just like to draw people's attention to HRVs as really important technologies.
Beautiful. All right.
You could stop sharing, Robert, so that all eyes are on me.
All right. And I'm going to head down into the garage.
Would you? Great.
Absolutely. Go, Nick.
All right. And you guys should be able to maximize me, I hope, so that you can see what I'm doing a little more clearly. This is my induction cooktop. It's by KitchenAid, nothing fancy. We've got an electric range below it. You can also get slide-in units like we did for the ADU. In fact, we bought the consumer report, the last one listed on that slide earlier. We bought that exact system with a built-in air fryer for about $2,000, and the tenants love it. But what I wanted to do with you today was I'm going to get some cold water straight from the tap, so you know I'm not cheating. And I'm going to boil it and cook some pasta. And in that way, I'll be able to demonstrate how these work in practice and why it really is a good, satisfying cooking experience to use induction. And I'll start with a story. Before Thanksgiving last winter, we tested the gravy recipe here on the induction cooktop. It came out good, you know, onions, mushrooms. And then we went to the rental where we had a gas cooktop, and I could not get it to work. It came out purple in color due to the wine, I think, and took forever. And so I'm finding induction cooking is a lot like driving an EV. Once you try it, it's difficult to go back to gas. So I've filled up this pot. It's an Emerald brand pot, so that tells you how old it is. Emerald's not on the Food Network anymore. It's just a standard, nothing special pot. And I'm going to select the burner I want, and I'm going to turn it on. Normally, I'd have the vent hood working even with electric cooking, because you do create ultrafine particles that need to be vented, but you don't create nitrogen oxide, importantly. And studies show The health impacts of that cannot be underestimated, especially for sensitive people with respiratory conditions. So you'll see this will come to a boil remarkably fast. We did a Pepsi challenge where one of Robert's friends has a side-by-side gas and induction cooktop. And we were able to show roughly half the time to boil the same volume of hot water. And that was a technique that the salespeople at Meritage Homes, when they built an all-electric induction cooking community in Irvine, used. As people were walking to the bedrooms, they said, okay, I'm just going to put on some water to boil. And by the time they came out after 2 minutes, they had a rolling boil. Nice way to demonstrate the difference. I also like the pinpoint controls. They're digital, so your younger homeowners are going to rally around digital controls. If you think about it, the size of the flame really doesn't tell you the level of heat you're putting into the pot. And when this comes to a boil, I know if I want a low simmer, I put it on 3. That's what I cook my oats on. If I want a little bit more, I put it on 4. That's what I cook rice on, and it doesn't boil over. So these controls you get really used to, and they're a pleasure to work with. The other thing is safety. You saw the Super Bowl ad maybe a few years ago. I think it was Frigidaire, and they showed the little kid, reaching up over the countertop with their little fingers around the induction cooking surface, and there's no heat because it's delivering heat directly into the cooking pot or pan. In fact, I will, when I'm cooking something, even with a plastic utensil, I will lean it up against the side of the pot, because it's going to take 20 minutes for that to get hot. So there's real safety advantages, real ease of cleaning advantages, none of those terrible nooks and crannies under the grates that you have to clean. Maybe you can hear that it's starting to come to a rolling boil now, and I'm going to add my pasta. So Ariana was saying that they're going to have an induction display in a public park, maybe this weekend. Be a great opportunity for you to try it. This is the sticking point for you on converting to all electric, because you really don't unlock the full economic benefit of heat pumps and heat pump water heaters unless you're able to go all the way electric, completely eliminate the gas bill, add solar panels. That's when the economics really start to sing. And I'm going to leave that for 7 minutes. I've got it on 4. I know it's not going to boil over at 4. And I'll have pasta in 7 minutes. Now, as I said, Channing Copper's making one of these where I've noticed that when I use the big burner in back here, that's 4 kilowatts of power. That's a lot. That's more than my solar panels produce at the peak of summer at noon. So the Channing Copper invention is a good one to reduce the peak impact of these induction cooking systems.
Okay, all right. I see you saying 11:45.
All right, I'm going to stop there. Robert, are you ready to take over and talk to us from your garage?
Hey, Nick, I'm ready. Nice
Awesome.
job.
Tell us about your experience with heat pump water heaters.
So as I mentioned, I waited. We actually delayed our construction because I thought these were such a game changer, and we were considering solar thermal panels for our roof, and that's where we were. And then thinking about how we paired those, and solar thermal was the thing back then, and there were all kinds of incentives for putting solar thermal on, but when I looked at the technology, they have a 10-year warranty, but I never saw a system that actually lasted 10 years without a major retrofit. You had to put glycol in them. There's pumps, there's electricity, there's all these moving parts and pieces, and they took up a significant portion of my roof. And then I realized that putting hot water into my heat pump hot water heaters was not most efficient, in that it instantly changed the dynamics of them. And by putting hot water into my heat pump hot water heater, the heat pump portion of it would tend to turn off, because it wants cold water to actually condense the refrigerant. It uses that cold water as part of the cycle to condense the refrigerant that helps the heat pump cycle actually work. So we scrapped the idea of the hot water panels, and we went with all PV on the roof. And pairing PV with heat pumps is a really good idea. That just takes the complexity out of it. And so I want to show you the heat pumps right now. We have two of them. And this one right here is the one for domestic hot water. That is my showers, and the hot water at the tap in the kitchen all comes from this tank right here. And you're probably wondering, what's going on with the cardboard here? And the reason we want to separate these tanks a bit is because I don't want the cold air from this one blowing into the inlet of the next one. The next one over here runs my heating system, and I have basically a loop of hot water that runs around baseboard heat radiators, and it's really very simple system. But just to focus on this unit for a second, this is the original unit that we bought 10 years, almost 11 years ago now. Has worked perfectly, flawlessly since then. And it has some features on it, which I would like to talk about, because it does some things that other hot water heaters can't do. One of them that I love is the vacation mode. So I can hit this vacation button, and then a menu comes up that allows me to program out so that the unit essentially shuts down for up to 14 days. And then I can program it. So if I'm gone for a week and a half, I can program it to turn back on the day before I come back. And other than that, it will sit at a nominal temperature and do nothing, because it's programmed to just keep the water at 50 degrees. And so here the water is coming in from the street at 50 degrees, so it does nothing. So that's a feature that we really, really like. It's an energy saving feature that I use every time I go on vacation. There's another feature that is its power mode, and you basically have an opportunity to program in that it only uses the heat pump itself. And the heat pump is the portion up here. It has a resistance heater underneath this cover right here, which is a 4,500 watt resistance heater that would be the equivalent of an electric tank. So it actually has the functionality of an electric tank with this heat pump hot water heater onto it. So if you compared it to a regular 50-gallon electric tank, it actually has more recovery capacity because it has the heat pump on top of it. So it's actually a little bit more robust than what a normal tank would be. So this easily replaces an electric tank if you have an electric tank. But it has some extra features, like I said. So we can lock out, and that's what we've done here. We've locked out the 4,500 watt resistance heater, and we only use the heat pump heater itself. And that means that it only will use up to 500 watts and not the 4,500 watts from here. So it significantly reduces the load profile of the unit as it's going. The other thing that is just really simple, there's virtually no maintenance to the thing. There is a filter, an air filter on the back that once a year I take this out and I wash it off with a hose. And then every 5 years, I do the normal maintenance that you would do on any tanked unit. I replace the anode rods inside, which means the tank will last longer. And I drain the tank once a year. At the very bottom of the tank, you just plug a hose into it, and that's sort of normal maintenance. But the beauty of this unit is that it takes in the heated air, just nominally heated by the sun in our south-facing garage, and it pushes it into the water at an incredible efficiency. Again, about 350% efficient. And it takes the air in here and it blows cold air out the back. And the reason why I have these pieces of cardboard is to make sure that the vents from one unit don't blow into the other. I see that too often, that the even in HVAC units, that they face the units to each other and they actually blow cold air into or hot air into the other side of the thing. And we just want to avoid that. So so this is the 50-gallon unit for domestic hot water, again, showers. And then we have a second unit, and I bought an 80-gallon unit for the hot water system that basically heats the house. And it's a when we went on tours of greenhouses, we always came to a place that looked like like the boiler room of a submarine or something. Just all of this plumbing and all of these dials and just, you know, stuff that I wouldn't want to build and I wouldn't want to own and maintain. And so we wanted to keep our house as simple as possible. And so you can see here, there's one inlet, there's one outlet. Here it's a little bit more complex, but not really. It's basically an inlet and an outlet for the hot water and a pump that circulates that hot water around the house. And all of that has worked really well for the past 6 years, I would say. And then the climate has shifted. And so it's gotten hotter here. And the engineers have actually calculated a 4 degree delta. And they calculated with our overhangs and everything that we would not need air conditioning, even if the temperature here rose on average 4 degrees. But unfortunately, the summers are getting hotter. And if I was to do this again, I would not actually do this whole thing for 2 reasons. One reason is heat pump technology gives us air conditioning and heating at the same time. I would probably put more ventilation in conjunction with an HVAC system, as Nick mentioned, an HRV or something along those lines that could give us both heating and cooling. It's not severe. We're close enough to the ocean that we do get cool breezes, and we mitigate the heat by drawing the shades and doing other things to do that. But at this point, I would make a different decision. I just wanted everybody to know that I would make a different decision given climate change and specifically the fires. We want to be able to have clean, fresh air and a cooled environment, especially in the summer when there are fires, and the mitigation from that kind of thing needs to be thought about. This unit does not give us that capability. The second thing that we learned is, again, this is pumping a loop of hot water around. So warmer water is coming back to the unit, which makes it less efficient. And sometimes the heat pump will kick off if that water is too hot, and then it's only using the resistance heater to heat the water. So it's not the perfect solution. And I would do it differently today than I would have done it, 10 years ago. But you live and learn, and I wanted to share those experiences with you. What else, Nick?
Robert, there was a question early on about heat pump water heater location and the concern that it would produce a lot of cold air and make the space uncomfortable. Is that your experience?
That's a great question. And Nick, you and I tested. We actually brought a decibel meter down here to figure out how noisy this thing was. You had a client that asked that, and we put a decimal meter on these units. These are older units, so the newer units are actually more quiet than these older units, and we read them at 40 decibels, if that was right.
40 to 50
decibels, which is about the same kind of noise that a high-end dishwasher will make. So they're not perfectly quiet. They do click on and click off a little bit, so I would not recommend these for a place right next to a bedroom, for example, right, in the same space. We're configuring them for our EPIC grant program in a vestibule outside the front door, right, with a fully vented louvered door so that you can get, the fresh air into them that they need. But it's a real concern in terms of the noise. In terms of the actual impact on the space in terms of overcooling the space, there have been a lot of studies done on this. that basically say the impact on the cooling in the space can be very beneficial to places like Palm Springs, for example, where it gets very, very hot, and it can minimize some of the load of the air conditioning by pushing some of that cool air in. And even in the wintertime, though, it does not have a disproportionate negative effect on the load in the building. Here in my garage, I minimally feel the difference because there's so much thermal mass in the garage that it just continually sucks out the heat of those pieces. It's never too cold in this garage. But the other thing that I like about it, and you can see I actually collect the water at the bottom in that bucket.
Condensation,
by code,
huh?
Yeah. It's condensate, but unlike a gas condensate, efficient unit, which has an acidic component to it, that's just fresh water. And so I just basically take the bucket, once every 2 weeks, and I throw it on my plants. And so it's actually clean, fresh water, maybe even drinkable, but I don't, I don't go there. But that's the level at which, and for me to have a dehumidifier in, and if you can see over here, that hole right there is a crawl space for the underside of my house. And so for it to be able to dehumidify my garage and crawl space for free, essentially, is actually a super benefit to the units as well.
Yeah, I'd agree. When I do energy modeling, there's not a huge issue whether you put it in an attached garage or an interior space. The amount of cold air, I think that was MD who made that comment, is not as outlandish as you may have thought. Also, Dave Intner comments in terms of noise, and my experience agrees with his. My gas tankless is loud. I hear it click on. I hear that combustion fan ramp up and roll. Got to be pretty comparable to these heat pump water heaters. So give it a little thought. Don't put it in the closet off your master bedroom. Yep. But there's plenty of places in your house, utility rooms, mud rooms, attached garages, and outdoor closets where you should be able to find space for it.
Yeah, there's so much latent heat, especially in Southern California, that it makes the units really, really efficient. Yeah. So it's really good. All right. Any other questions on these guys?
No, and I remembered, Robert, next is heat pumps, and to allow you chance to relocate, I'm going to take that piece. And we've almost caught up on time. So everyone, beautiful. I want to thank you for your consideration. This is like a super valuable focus group for the city of Santa Monica, because you're raising a lot of good questions, including the latest ones in the chat, which are setback requirements for utility closets and such. Can you locate these systems on a flat roof? So Ariana and her colleagues, I'm sure, are taking notes here, and we can extend our session if it's okay with them at the end to bring up more of them.
Absolutely. No, that's fantastic. It's a great group, and we love the interaction. So keep it coming. All right, yeah. I'm going to head back upstairs, Nick.
Okay, super. And I'm going to get back to our presentation now with heat pumps. We had the comment earlier that someone put a heat pump retrofit in their basement. Sorry if I didn't catch your name. It took up a lot of space. We'll talk about some alternatives that may not have taken quite so much space. And we'll start with a video here.
In the past, conventional electric heat pump systems were known for their poor efficiency and performance in cold weather temperatures. Today, advancements in modern variable speed heat pump and zoning technology gives everyone in the home year-round comfort, even in sub-zero temperatures. Here's how they work. Ultra-efficient variable speed heat pump systems consist of an indoor air handling unit and an outdoor condensing unit. The units are connected via 2 refrigerant lines. Working as a system, the units efficiently transfer the desired cooling or heating energy to each personalized comfort zone. In summer, air conditioning is produced when heat energy from inside a home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed, and the system extracts heat from the outdoor air and transfers it inside to heat the home. When compared to fossil fuel burning systems, modern variable speed heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option. To achieve this, variable speed inverter compressors use up to 40% less energy than past conventional systems by modifying the compressor speed up or down as needed in order to maintain consistent, comfortable indoor temperatures, a feature conventional systems simply do not have. As an added benefit, some systems allow a single outdoor unit to control up to 8 indoor units for added comfort, efficiency, and styles within a home. Ductless indoor units circulate and filter the air already in your home, resulting in improved air quality with whisper-quiet operation. Today's revolutionary inverter compressor technology is an impressive advancement in residential heating and cooling. These smart systems regulate energy consumption, using only the precise amount of energy needed to keep a home comfortable, saving the homeowner money while reducing our carbon footprint.
So hopefully that was a helpful video, and hopefully you were able to hear it, looks like it, to understand heat pumps, reversible air conditioners in a simple way of thinking about it. And the visual during winter, I think, really helps people get over that hurdle of, wait, how can you heat a house in winter with the outside air? There's enough heat present in that ambient air, especially in California, using the compressor cycle to heat a house practically. So we showed the ductless mini split with that video. There are lots of other configurations, though, that I want to make sure you're aware of as you go about building new all-electric homes with heat pumps and retrofitting existing homes with heat pumps. They can often be lower cost to install because they're simpler, a single system providing heating and cooling in one rather than two systems, a gas furnace and an air conditioner working half the year each. And often no ducting. A quick note, there's been a change in efficiency regulations at the federal level starting January 1st. So we used to express the efficiency of our heating and cooling units in terms of SEER and EAR and HSPF ratings. There's a new test method. We're now going to be talking about SEER 2, EAR 2, HSPF 2 ratings on our equipment. And so what's happened here is the code has gotten a little more stringent in the minimum efficiency. You can think of them as what used to work as 14 SEER will now have to be 15 SEER. That's the cooling efficiency. But we're now going to express it in terms of this new metric SEER 2. So the new federal minimum efficiency for an air conditioner or a heat pump is 14.3 SEER 2 and 7.5 HSPF 2. That's the heating efficiency. So for more information, you can go to DOE or your HVAC manufacturer on that. I just wanted to spend a quick note. Now what you see here are the ducted mini split version. They can be hidden away in a drop ceiling or soffit, as shown here, with short duct runs. And you notice the Rick Chitwood is shown on the right there. He's behind a lot of the innovation in Title 24 around HVAC and high performance homes, really a legend. And he alone, despite his engineering degree, can lift that indoor unit. So these are very practical to install. They link to the same outdoor unit as the ductless mini splits do. You see that at his feet. And those outdoor units, to a question earlier, need to be installed outdoors. They need a free access to outside air, both to expel heat during summer and pull in heat during winter. Can't be put in an attic or a mechanical room. But there's going to be a steady flow of refrigerant between that indoor unit and the outdoor unit to provide heating and cooling, whether it's a ducted mini split like this or a ductless mini split as we showed in the video. So think of it as a single system to do heating and cooling, no gas lines needed, no flue vent pipe needed, no combustion gases around your building. And those outdoor units and the indoor units are much quieter than standard air conditioners, to the point earlier that Amy made. She was worried about the noise of replacing her outdoor air conditioner with a heat pump. On the contrary, that's not something you need to be worried about. These are the only way to meet some noise restrictions in tight lot line areas of LA. And utility bill savings. We'll talk about that in a minute. In terms of first cost, though, we did a survey of Southern California HVAC contractors under a different study, and we got a range of estimates for a gas split system in an addition scenario. We're adding 600 square feet, between $6,000 and $15,000. We got a range of estimates between $6,000 and $13,000 for a single central heat pump. And these are like for like efficiencies, 2 tons. So every contractor gave us the same or lower bid for a heat pump versus a gas split system. So if you're going under the assumption that split systems, gas furnaces are cheaper, you may be surprised, and go start asking for some quotes. There are also packaged heat pumps. This one on the left, so instead of split system, package units have all of the equipment in one package. The one on the left is called Epica. It's an Italian manufactured product. It's got 2 through-the-wall ports that are bringing in outside ambient air for heating and cooling, depending on the direction, and venting the condensate. They atomize the condensate and blow it out periodically, so you don't even need a condensate drain with that unit. The one on the right, a more traditional packaged heat pump. The ductless mini splits are the best in class in terms of efficiency, as shown in the video. You've got an indoor unit and an outdoor unit, but I want to make sure you come away today with an understanding that there's all different types of indoor units: ceiling cassettes, high wall units as shown here, floor mounted units, hidden ducted units, so you can have traditional aesthetics on your registers, which many homeowners demand these days. They don't like this high wall unit exposed. I personally don't mind it a bit, but you can do that with the ducted mini splits, with the ceiling cassettes. But these get to the best efficiency because there's no ductwork to lose energy in. You can link multiple indoor units to one outdoor unit. That's what I did for my ADU. There's one in the bedroom and one in the living room linked to a single outdoor unit. You can even link high wall units indoors with ducted hidden away mini splits in other zones of the house and the same outdoor unit. So get with your HVAC contractor on what's possible with these. But you saw in the video, they emphasized the fact that instead of just being on and off like a jet engine, cycling on and off like the air conditioners and furnaces we grew up with, these modulate. So a lot of the time they're just cooking along at real low load. They're almost silent when they're running like that. And they're very efficient when they're running like that. So I found that my ADU's ductless mini split runs more hours than my air conditioner and heater runs in the main house next to it. And the main house is 3 times the size, but they use half the energy as the main house because they're running so efficiently. So quick note on this, we're used to number one. We're used to installing a furnace and an air conditioner in every house with ductwork up in the attic, with a vent for the combustion gases, with a gas line up there. It's a complicated system, and more complicated than the other 3 heat pump systems we're showing here. Whether bottom left, the best efficiency in class, the simplest version is that ductless mini split. The ducted mini split in the bottom right, the next simplest, shorter duct runs typically, but you don't need gas, you don't need the flue vent pipe, or the conventional central heat pump, which is the closest cousin to what we've always done with gas furnaces, except we eliminate the flue vent and the gas, still with big fans and lots of ductwork and potentially duct losses up there in the attic. So best practice is really 3 and 4, the ductless units, or the ducted mini split units can be also very efficient if the ductwork is on the conditioned side of the thermal envelope. If those ducts are in drop ceilings or hidden somewhere away, that's when you really unlock the full efficiency of these systems. And here's a ceiling cassette I really like the aesthetics of. You can see there's a little drop ceiling there where the mechanics of the unit are hidden, and that's providing single direction cooling and heating to that kitchen space. This 4-way ceiling cassette is in the middle of the ceiling, providing the same to the whole room. So they can allow you to get away from the high wall unit aesthetics, as can the ducted mini splits, and you can have really attractive linear diffusers like shown here that are great for the Santa Monica modern style home. And they're really efficient. The ADU I have with 2 people living in it, you can see the electricity usage during summer. And then where did those bars disappear to in November, December, and January? Almost no heating required to heat that ADU because the ductless mini split's efficient, the envelope's efficient, excuse me, and there's natural interior gains in an efficient envelope situation that can almost eliminate the need for heating in climate zones like ours. In contrast, the main house used almost double the electricity to heat it for the same number of people, to cool it in summer for the same number of people, and it continues to use gas and the forced air unit all winter long to keep us warm. So the energy comparison, heat pump to split system, really advantages the heat pump, and that's where the biggest cost savings, according to my modeling, are in electrification. They're in the HVAC heat pump. Any questions, Robert, before I plunge into the energy modeling side of the all-electric argument?
No, I think we're good, Nick.
Anything you want to add on heat pumps?
I just wanted to add that you did an excellent job in insulating and air sealing on your ADU. That I think also, we just can't emphasize enough that if you start out with a building that heats and cools itself, the mechanical loads are so much less. And guess what? You pay for the architecture once, but you pay for the mechanical systems over and over and over again in their operations and maintenance and replacement over time. So if you can reduce the load and get a 1-ton heat pump instead of a 3 or 5-ton heat pump at the inception of the building, that means that when it needs to be replaced, and they all need to be replaced eventually, you only need to replace that 1-ton heat pump as opposed to the 3 and 5 down the line. So it's less expensive over time to really mind the shell. And you did an excellent job with insulation and air sealing on that unit, which I think was, very well done.
I've been shocked how little heating energy it needs, 10 kilowatt hours, in the depth of winter per month. Hey,
Yeah.
One question I'm noticing from my list, Susie asked about gas cooking and food service. Do you have any experience with restaurants so far, Robert, and switching them to induction?
Yes. The short answer is they're resistant.
Mm.
That is the short. They're still resistant. There's still a culture of that I earn my stripes by the burns that I have on my forearms. Literally, it's sort of a rite of passage that these irons get up to 3,400 degrees, and you literally will sear yourself on those things, and it's a rite of passage kind of thing. But the best cooking schools and the best restaurants in the world have all moved to induction. So I think it's just a matter of time, but there's still resistance from two factors that we've seen. One is the one I just mentioned, just inertia. And the second is the sense, especially with ethnic cooking that we've seen, where, hey, I need to grill my tamales and chilies on an open flame, and that's real. And I'm from an Italian family. We roast peppers. We do the same thing with peppers, and then you take the skin off, and you end up with roasted peppers, and the flavor is very, very different. And so what we've shifted to is a barbecue. A propane regular barbecue or an electric barbecue. We have both at this point. And so we get the full flavor of those things. But guess what? We don't use them every day. So the impact on, our carbon footprint and the cost of those things from an actual dollar amount and from a health standpoint are radically different when they sit outside. So we, again, maybe use it, I don't know, once a month in the winter, and then, a couple of times a month in the summer, but it's not actually polluting our indoor air that we breathe every day. And so the health impacts as well as the environmental impacts are so much less by using an outdoor grill to do those, ethnic cooking things, that it's a non-issue. We feel that, that's certainly anybody can have a little outdoor deck and put, a little hibachi, gas-powered hibachi on the outside to do that kind of roasting.
Right. And flat bottom woks are on the market for Chinese cooking. So they're developing solutions for all these challenges. Sorry, I stepped on someone.
Yeah. No, Robert, that's not a problem. Do you mind if I add one thing?
Please do.
Commercial lineups.
Yep.
We always we seem to be not myopic, but we concentrate on energy. But we find out a lot of times that there are a lot more costs than energy, and you can save a penny in energy and cost $1 somewhere else. What we learn on commercial lineups, kitchen lineups, is that the heat of a gas lineup does horrible things to the cooks. I mean, they're in a really bad working environment to the point that OSHA's looking at it now. And we've had, independently, chefs have put little temperature sensors on their collars and worked on an electric lineup, and they found that the electric lineup brings their working conditions, their working temperature down substantially, to the point that you don't have people going home sick. You don't have to do the OSHA breaks for people who are working in high temperature workplaces, things like that. And it's just one of those things that sending a cook home will cost you hundreds of dollars versus the electric savings or all of that. But that's what we've been finding independently of what we do on the lineups.
Great point, Nathan. Great point. Yeah, and they're breathing air, which is not optimal at the same time. Right. So the combination of those two things, and there's oftentimes, it's a strain on the HVAC system. They try to air condition those places, and it's very, very expensive to do that. So those things are working against each other. So great point. It should be easier to convince these folks, but I've just seen in project over and over again, and it's the reason for the exemptions, because there's such a feedback loop on this thing that even Santa Monica sort of gives an exemption. They say you can put it in, you have to dual plumb it, so it's twice as expensive as a result of that, but you can still do it. And it's unfortunate because the negative impacts of doing it are real, as you mentioned. So thanks for pointing that out.
Yeah, Jay, I'd love to get that data on the temperature in commercial kitchens. We could make a slide out of that. And point for Ariana and her city colleagues, the roadmap you created towards all electric buildings, I was reading over it last night. It's really thoughtful about some of these difficult challenges, existing buildings, food service, and the staged approach that you're taking to try to get there is I think the only successful way, because there is some resistance that we need to overcome in many of these pockets.
Yeah, very true. And I'm sorry, I thought it was Nathan. Was it Jay who was speaking or Nathan? I thought it was Nathan.
Sounded
I
like
could be
Jay Madden.
Okay.
I was on mute. It was Jay. Yes.
Yeah.
Oh, was
But
it?
I will dig up that information to help you out on that one. Thanks.
Super. Thank you.
Well, I had an energy modeling fan on in Helene. I hope she's still here. She asked about energy modeling electric. So let's look at that. Because there was a time, and when Robert remodeled his house was the time, it was tougher to get electric systems to meet Title 24 than gas systems. But I'm here to tell you those times ended last code cycle, and this code cycle, electric systems have an advantage. Why? Because now in the software, we have better predictions of the greenhouse gas emissions of gas versus electric. We have a grid that's going to go to 100% renewable energy by 2045. So when we take a look at the electricity that let's say a cooktop or a heat pump is going to use, we're able to have a better crystal ball prediction of the total emissions of that house than we were 10 years ago. And so you'll find that your electric designs outperform your mixed fuel designs in almost every case. Because heat pumps are prescriptive standard, we've got the source EDR metric now. The gas systems have to be electric retrofit ready, so they're a little bit more expensive than they used to be. And we've got some electric technologies offering significant compliance credits that the gas systems can't quite meet, including the variable capacity heat pump credit, which is designed for those mini split heat pumps we just went over in the prior section. The ductless mini splits have been perfect for the VCHP credit the last code cycle. I've used them on a lot of projects that were difficult to comply, and they got me into compliance. But the ducted mini split heat pumps were a little bit more challenging to meet the definition of VCHP, but this is a sneak preview. We're about to get a detailed VCHP compliance method that'll bring those ducted mini split heat pumps into some considerable compliance credit as well. You can expect that by the end of the year, I'm told, and I've been helping the CEC out on that modeling.
And Nick, can I ask about the packaged units? How do they work in relation to that?
Rooftop package units are often minimum efficiency and therefore don't qualify for any compliance credit.
Oh, I'm sorry. I was talking about the Epica.
Yeah, the Epica may well qualify for the VCHP once the detailed option goes through. Might even qualify now because they just need to have a wall-mounted thermostat and an indoor unit in every 150 square foot room, entirely in conditioned space. Yeah, I think the case could be made that those already meet the VCHP credit.
Nice, super, thank you.
So here's the compliance impact in terms of the efficiency EDR of the heat pump. And I modeled just a standard central heat pump compared to a gas furnace split system. That's the yellow bars. And you can see there's a smaller positive impact for the central heat pump than for the VCHP shown in blue. That's the ductless mini split. You can see efficiency EDR impact. Let's take climate zone 6 where we are in Santa Monica. The impact of that's about 3 to 4 EDR points. On a target of 40, that's a huge impact. It may look like a small bar relative to some of the other climate zones, but it's huge. Even the central heat pump at 1 EDR point is valuable on some projects. And you can see for your projects outside of the mild climate zones, VCHP's impact's even bigger. So this is a real helpful tool for compliance. Utility costs. I didn't want to leave the economics of the heat pump switch untouched. SCE funded the development of a calculator, which you may be able to find still on their web page, where you put in the old system you have in an existing house, where you are, what rate plan you're on. You put in the heat pump you're considering replacing it with and what rate plan that'll put you on, and it'll predict the cost savings and energy savings and greenhouse gas savings of the transition. And this is based on modeling runs that we did in advance for all these different vintages of homes, so that when someone sits down at the kitchen table with you, the homeowner, or you sit down with your client, you can take away some of that fear factor around, well, isn't electric heating going to cost me more? We realized this was a key impediment, so we built this tool. And some of the comparisons are shown in the chart on the right. For SCE territory, you'd be similar in Santa Monica for your CCA power. But you can see the gas split system has overall higher whole house utility costs than the ducted VCHP, ductless VCHP, and the central heat pumps often just a push. So when we talk to people about heat pumps, we first need to start with the comfort argument. Quality of life, wins the game better than specs and dollars do, in my experience. So talk to them about the fact that the inverter technology on ducted and ductless mini splits will ramp up and down according to the temperatures in your space and outside, and just cook along quietly in the background until needed, until that really hot and cold day, in which case it'll ramp up and do the job and just maintain your indoor environment at the temperature set point you want. You won't notice it blowing your hair in the wind. Of course, that doesn't happen to me. You won't notice that rush of heat and then the stop. You won't notice that really cold air and then stop. But isn't that really more comfortable, not less comfortable than what we grew up with? I would argue yes. It's just a different paradigm. Also realize in Santa Monica and most of Southern California, there's no need for heat strips. There's no need for supplemental electric resistance heat to augment the heat pump cycle of our HVAC equipment. We've got plenty of ambient heat in the air, plenty of ability to vent that heat in the summer. We don't need heat strips in winter. Those are Minnesota, Maine, and they turn on just when they've got the really peak design day, really cold day. The heat pump gets you most of the cooling, and the electric resistance heat strip just augments it as needed. So try to get equipment without them, and certainly be conscious and make sure they're not turning on in error due to some misinstallation. Which brings us to commissioning, which is what Robert's going to talk about in a minute. I noticed when I installed the ductless mini split in the ADU behind me, it was turning on late at night and running full blast. And I asked the tenants, I didn't ask them, what are you doing up there in the middle of the night? But they told me, it seems like in the bedroom, it just blows hot air in these really hot nights and we're uncomfortable. So we called the contractor out. It took a few times to discern the problem, but what was happening was the cooling coil was turning on in the living room indoor unit and the fan was turning on in the bedroom indoor unit and vice versa. It had been miswired. So you were getting condensate dripping onto the floor of the living room the next day. That was one of the clues that helped us find the problem. But the energy monitoring system too helped us discern the problem. And Robert's going to talk more about that based on his experience in multifamily buildings in a minute. The heat pump clothes dryers, as I said, my experience has been great. You trade off slightly higher first costs for energy savings and more gentler treatment of your clothes. And the heat pump water heaters, we talked about locations, we talked about needing a constant source of ambient air around them, either through a louvered door or ducting or just a large room. Careful the heat strips don't turn on. You should be able to run those in heat pump only mode. Talked about recovery rates and maybe needing one size larger than typical for a gas tank. Peak shifting and aiding the grid. This is a key technology to help the grid, support the grid by absorbing excess solar in the middle of the day, heating the water tank and coasting during peak periods so it doesn't add to the peak that the grid's facing. And there's compliance credit to be had for these heat pump water heaters too. Be sure though that you're modeling NEA Tier 3 rated heat pumps with the make and model indicated in the energy model, i.e. Bradford Wright, A.O. Smith, Rheem, and the model number, because I find that really unlocks the full compliance credit of the heat pump water heaters. You can also model them as generic, which gives you more flexibility for what you install in the field, but you don't get the full compliance credit. So if you're running into that, talk to your energy consultant about the make and model. And we find they have comparable operating costs to gas. I told you HVAC heat pumps have significant savings associated with them. Heat pump water heaters are roughly a push. And we modeled PG&E, a bunch of climate zones up there, where if anything, they're getting colder ambient air and running less efficiency than they would be down here. So think of it as roughly a push. And then there's significant compliance credit for recovery ventilators. I showed you earlier those energy saving ventilation devices that also duct the fresh air and exhaust the stale air on a continuous basis where you want it with dedicated duct systems. These are a great problem solver for difficult to comply energy models. So when we tie all that together, we see a huge swing between dual fuel designs. This one's running Climate Zone 10, Inland Empire, and all electric designs. See how the compliance margin has gone from -11 source with the mixed fuel to +5 with all electric. The efficiency EDR score from -4 to 2, the total EDR -2 to 1. So gone are the days where electric's harder to get to comply. It's easier to get to comply. And when you compare mixed fuel to all electric in the 2022 code, the impact on efficiency EDR and source EDR is on average 16% efficiency, 50% source. Remember I said that source EDR is going to be especially sensitive to gas. Well, here you see it. So if you're not getting the feedback from your energy consultant that all electric will work for your project, ask them some of these questions. Are you on the new software? Isn't all electric now roughly equal to or better than gas for compliance? Did you use VCHP? Did you model a specific make and model of heat pump water heater? And if you still don't get satisfaction, ask them to send you the energy use summary from page 2 of the CF1R form showing, are you falling short on heating or cooling or water heating or ventilation? That'll give you some clues on where you need to work on. Recognize that all electric is not a fad. It's not at the early adopter stage at all. It's at the mature technology stage. And companies like Meritage with this City Square project in Irvine that was all electric, Net Zero Energy, City Ventures, from what I understand, only builds all electric in California now, are doing it everywhere and having good pace of sales, demonstrating this can be done. Here's a Tim Kohut project. We mentioned him before, really respect his work for National Core. Here was a new affordable 100-unit building in the Inland Empire with a lot of hot and cold. And they were able to do it all electric with a heat pump water heater for every unit, a mini split heat pump for every unit, and cobbling together resources, rebates from all these California programs we're able to make it pay and be cost neutral versus the traditional way of building with gas. There's even a means that a builder like National Core can build these net zero, all electric buildings with lower utility rates for the occupants. And because that occupant is going to have lower utility costs, that's the responsibility of the state program, the rent can be increased commensurately. So in this case, a typical utility bill of a typical designed unit was predicted to be in the $150 a month range. But National Core upgraded it, added PV, brought those expected utility bills down to the $15 range. And those savings added up to an additional $160,000 in rent for that building owner, just waiting there through the QAC process to be claimed. So Tim's figured out the economics here, and he'd love to tell you how to do it yourself. Robert, do you want me to page through these as you speak to them?
Sure, that'd be great, Nick.
So, any questions before we start?
I think we're good on the questions, actually.
Super.
Ariana is asking for the group to, give their feedback on a form. So she gave the link there. But I think we're good in terms of the questions and so forth. So, so for the last 7 years, I've been auditing, as I mentioned, affordable housing complexes, portfolios of buildings, and the stuff that I see is quite amazing, and both the good and the bad. And Tim, through National Core, has done a great job here. And some of the things that you're seeing are subtle, but really, really important in that he's using the footprint of the roof in a generative way. He's putting the solar in the middle of the roof. Too often I find projects, and you'll see them, that have used the best part of the roof for solar for the HVAC systems. And they put the compressors up there right in the middle of the roof and have destroyed the value of the roof. I say the roof is the engine of the building. And we're finding that more and more because you can only generate solar, from very few places, and the roof is the least expensive. A lot of people put carports up, but they're more expensive per kilowatt of energy because you have to erect a structure. You are already building a roof. The question is, how well are you utilizing that roof, or are you dismantling your engine as a result of doing the wrong things the wrong way? And so here you can see them putting the HVAC units against the parapet wall. That's a very, very good use of space. And then using the solar for the center of the roof of the building. Next, Nick. And unfortunately, this building, they did not do that. So they put the HVAC systems on the roof, and they put a hot water generation system on the roof as well, which was not working optimally, to put it simply. And then so they decided to try to generate electricity by putting this array on the south side of the roof. And so what do you guys see as a problem potentially? Did you guys catch it? Yes, they actually planted that tree, believe it or not. And so over years, it had grown up in that space. And if you know anything about solar, especially with the old inverters, if one of the panels goes down, all of the panels go down in that inverter. And so if you shade a panel, it goes down and it takes the rest of the array with it. That was happening. And then I walked over to the inverters, and the inverters had error messages on them. So I asked the maintenance guy who was walking around with me, I said, so how long have the inverters had these, errors? And he said, I have no idea. So I went back and I got all the bills and I looked, and this array had been out for about 6 months and no one knew, essentially. So, this is one of the missteps. It's absolutely possible to do all these things. And there's a few tricks of the trade. And that's what we want to show you. Is one of them somebody is going to get an email that your inverter went down. There's an email that was sent. Someone got it and someone ignored it. So if you're the kind of organization or kind of individual who will not catch that, you might want to do something else from the way you purchase your energy. And I never, as a finance person who's trained in finance, I would never recommend leasing almost anything. It's almost always better to purchase that thing and then use it over time. But in that scenario, then it would be better to lease, because the leasing company who's selling you the energy that they make is very, very incented to catch any problem in generation. And they will instantly roll a truck out to the site to fix the problem, because they know that they will pay for it over time if it's not fixed correctly. So that's one of the things. Next.
Yeah, Robert, I'd say, can you hear me?
Yes.
The ADU, I had the same thing. I had microinverters on our panels, so each panel worked independently and could be shaded without interrupting the whole array. But one just never was working. And I didn't discover it until they hooked me up to the app and I could actually see it. And then, you know, production went up 12%. So at a minimum, even if you don't install an energy monitoring system, hook yourself up to the app. Give yourself a reminder to log in once a week and make sure it's still producing, or at least look at your Edison bill every month. Don't just pay it, you know.
Yeah.
At least then you'll catch it before 6 months have come on.
Yeah. And I did the same thing, Nick. We were, you know, in a sprint when we were building our building, and you know the feeling, because we were out of our building. We were renting a place, and we, you know, had timelines, and we're, you know, so you're paying your mortgage and you're paying your rent and all that kind of stuff. And the first thing I wanted to do was finish the roof and then get the solar on the roof. So that's the first thing we did. I called the solar guys the second the roof was done, and, you know, we had the stanchions all there and they installed it, and, you know, and everything was going. And it wasn't until 6 months later when we actually moved in. And then I sat down and I had a minute to look at the Edison bill, because, you know, when you're dealing with a steel bill of $12,000 versus an Edison bill, you know, you don't look at the Edison bill. So I didn't look at the Edison bill for 6 months, and I went back and I like, this doesn't look right. I don't know what's happening with the solar. And it turns out half of my array was not even on. It wasn't even working. So for 6 months, I lost all that, you know, all that energy, all that credit. So exactly what you're saying is make sure that you look at these things and go through them. And if you can't, then do something different. So I agree with that 100%. The other part of it is the infrastructure. And I see this too often. This is a LEED Platinum building, built with the utmost of great intentions. So it's not that these people don't care. It's not that these people were trying to do the wrong thing, but the execution was atrocious. And just thinking, you know, you guys take a look at this now. Now you know what is going on here, right? You are looking to generate electricity from the sun, and then you need to think about how you configure these things. In the center there is the gas-fired. There are two boilers, and that's the gas-fired hot water system. And as you can see, it is expensive and complex to build that thing. And we want to completely eliminate it because it's sitting in the center of the roof, which should be the place where you're generating a lot of electricity. And you can't, because it's sitting in the center of the roof. But what's even more egregious is they put a solar thermal system to the front of that, which is shading the solar electric system. And then next. Mm-hmm. And you can see the solar system. This is the same rooftop. And so the parapet wall, as you see on the left, is shading the first set of panels. And the first set of panels is shading the second set of panels. And this is approximately December 20th, when you need this heat the most. And it's about 2 or 3 o'clock in the afternoon, when you should have been maximizing the effect of this, you know, solar gain. And you've crippled, you know, the solar gain from the solar thermal and the solar PV all in one spot. And to give you an idea how badly this was planned, you can see the walk-off mat And the walk-off mat is going underneath the solar array. So something did not get executed properly. And we find this all the time. It's one of two things. It didn't get planned properly in the first place, or at the 11th hour, so the last mile, something went wrong in the execution of it. And those are the two places that oftentimes, we just see problems. And we're trying to work with the developers to eliminate those problems. So advance, Nick. Yeah, this is another LEED Gold building. And if you guys look at the compass, that'll give you an idea of what's actually happening here. So the best orientation for solar in Southern California especially is southwest. The reason for that is, again, we talk about time of use. If you oriented them south only, then you would miss in the summertime a bunch of the most valuable solar, which when the sun comes down in the summer, it comes down in the northwest sky. And if you oriented your solar panels south, you would miss all of that solar game. And so what you want to do is orient southwest so you capture some of that gain. And even some of the panels can go west, depending on the building and the configuration. But they did the opposite here. They actually put the solar array facing east. And what we know about June gloom and a number of other things is that the sun might not pop out in June when you get the most solar gain until after noon. And by the time it's out at noon, the sun has already passed over the solar array at that angle. And so they were getting minimal solar production from that array. And they actually had rooftop that would have been optimal for the solar. And you can see the top and the bottom roof structures are covered with HVAC compressors. And again, just a huge missed opportunity because they didn't look at the roof as the engine of the building. And there's no chance at this point that anybody will have the money to reconfigure anything like that in the future. You have to do it right the first time. Next slide.
Let's wrap up so we have some time for questions, Robert.
Yep. Next slide. And this is how you do it, essentially. The blue line is the amount of control that you have over a project, and the red line is the amount of money you spent. And you can see that there's an inverse correlation. The more money you spend, the more decisions you lock in, and therefore the less control you have over the project. That's oftentimes where you do the design, right at the intersection of those 2 points. And this is what we want to emphasize. To do the design in advance of that, what gives you more control and options. And that's why you hire somebody like Nick and myself early on the project. I'm getting involved in projects where they are thinking about buying a piece of dirt, and they want my opinion on how this thing will stack up going through the process that we're talking about now. And that's when you want to engage a modeler. That's when you want to engage somebody like myself who understands how this project might go from an orientation standpoint, from the transformer standpoint, and just the electrification of the site standpoint. And that's where you can really make a difference in the project. Too often we get pulled in at the end of the project where they want to green it up or something else like that, and that never works, essentially. Next. All right, and this is my favorite modeling project that Nick did a while ago. Please, Nick, tell them how this works.
Is we've been modeling single-family homes so far in terms of the impact of all electric. Here's a nod to multifamily, a significant size, 36-unit, 3-story building. We put it in Irvine. And we first modeled it with a gas baseline, a typical mixed fuel design. And then we modeled the impact on TDV efficiency and source metric of several upgrades. And you can see upgrading the central gas boiler, because we had central water heating on this building, was a pretty nice boost to the efficiency, the TDV, a much smaller boost to the source. That was, in a way, the biggest bang for the buck on a gas system available. Upgrading the air conditioners in the units gave a nice boost for TDV, 2 TDV, sorry, very little for source. And high performance walls, triple pane windows, smaller still. But going all electric with just a regular central heat pump, individual heat pump water heaters gave a huge boost for TDV, and going all electric with ductless VCHPs, far and away the biggest compliance credit you could get, better than even the best gas upgrade that we might have drawn on in the past. So the ideal all-electric home, if you piece together all the parts that we've covered today, starts with a high-performance envelope, well-sealed, you know, keeping a good layer of insulation and separation between you and the outside environment, with passive solar orientation, well-shaded windows on the south, so that free heating can come in when the sun's low in winter and be fully shaded in summer. High efficiency ductless mini split heat pumps or ducted, you know, next best choice. NEA rated heat pump water heater, heat pump clothes dryer or electric, induction cooktop, electric oven, recovery ventilator for those fresh air benefits and energy savings we talked about, LED lighting, that's a no-brainer, and sizing the PV to cover the electric use of the building and not go over it unless you're building a little extra solar for future electric needs. Pair it with a battery, even better, right? That's the incentive that the utilities and the incentives are giving us. Pair it with a battery. So the reason we're here talking about all electric homes in Santa Monica, the technologies are proven and ready. The systems are lower cost, first cost and operating costs. Huge greenhouse gas difference. That piece I didn't understand when I remodeled my house with gas in it. Healthier indoor air by virtue of not having combustion in the space, and a recovery ventilator boosts that further. Big Title 24 compliance boost to do these things. So compliance is going to be smoother. Your uses use the same kilowatt hours as your PV panels produce. So there's a compatibility and a synergy there that works well, safer from those hazards. And we put together a lot of resources here, including RMI, including the websites of my house and Robert's, Net Zero Nest Green Idea House, Energy Vanguard, my favorite building science nerd online, Green Building Advisor right behind him. Architecture 2030 does a great job of communicating the urgency around this transition. The E3 study we referenced a few times, etc. A lot of tools for you here. We also gave you incentives in that earlier slide, both federal and state, that you can cobble together to make your all-electric project work economically. And here's our contacts. We'd love to hear from you. Your feedback from the field is so valuable as we teach additional groups. And with that, I'll turn it back to Santa Monica and let you tie things up and handle any other questions.
Great, thank you so much, Nick and Robert. This has been a very informative and really great discussion. As you've mentioned already, you know, it's great to see so much interest and engagement. There are certainly no shortage of challenges ahead, to particularly on the split incentive side and making this accessible to renters and multifamily buildings. But you know, it is very promising, I think, to see just how much progress has been made in the technologies, looking at the real savings that you've outlined. And I think this is definitely a very valuable resource. And as I mentioned in the chat, we're going to be sharing the recording and transcript with everyone who registered. So really appreciate you all spending the time here today to learn more. And please feel free to reach out to us with any additional questions. If you haven't had a chance to take this survey, that would be great. And yeah, we're just really grateful to have everyone here. And thank you again so much to Nick and Robert for this really interesting and engaging discussion. Really appreciate it.
It's our pleasure. We enjoy it. Absolutely. And I did see a question about continuing education credits for
Oh, yeah.
architects. Just want to make sure that people get
I just put
their.
in the chat. This class does not qualify for the ZNCD credit at this time. It hasn't been screened, although of course it could. But Energy Code ACE has a number of offerings that are, and stay tuned on that. Maybe Dave Intner and Jay Madden will help us qualify this one.
Yeah, that would be great.
That's super. And Nathan, did you have your hand up? Just wanted to see if you had a question.
Might have been left over from before.
Could have been.
We had a number of hands up when we got to that one section. So I'd love to go back into those topics if anyone would like to.